Out in space, there are places where gravity's influence is so intense that not even light can escape. These are known as black holes, objects with extreme gravity caused by extreme density that have an extreme influence on everything that gets too close. Often the subject of science fiction, black holes are science fact, but they're often misunderstood, as black holes aren't exactly holes. So let's investigate. What are black holes?
A black hole is an object so compact that not even light can escape its gravitational potential. That's exactly where the name black hole comes from. It's black because it emits no light.
Black holes used to be just a mathematical curiosity, but in the 1950s, 1960s, we actually realized they're out there in the universe. We know that there are black holes that have stellar masses that are born from the gravitational collapse, from the death of stars. We also know that there are much bigger black holes that sit at the center of galaxies.
The critical thing to remember about what happens with anything that's near a black hole is that black holes don't suck. You can orbit a black hole just as you can orbit any other star or any other massive object. Because there's so much mass in such a tiny volume, you can get a lot closer to all of that mass.
As matter falls in towards a black hole, it starts spinning faster and faster. It will naturally form into a disk. We call it this accretion disk because that matter will accrete onto the black hole. And that disk gets incredibly hot, incredibly bright.
A couple of years ago, we had the first image of a black hole, and that looked like a donut. But the donut was the matter around the black hole, and the black hole itself was just the dark, ominous void at the center.
Black holes have extreme physics going on around them, all sorts of crazy things happening. Your perception when you get very close to a black hole is that time is slowing down.
If a human traveler got too close to a black hole, they would first fall through, feeling nothing, until the point of spaghettification, where they would be stretched into a cosmic noodle.
When a star is passing by a black hole, one side of it gets greater gravity than the other, and so you get this very stretching effect. And so the star can be torn apart. This is what's called a tidal disruption event.
What could be inside of a black hole? The most commonly accepted answer is a point of infinite density that we cannot really describe well. At this particular region within a black hole, all of our theory of general relativity breaks down.
There's all sorts of ways of finding black holes. You can find them from their emission at certain wavelengths, like in the X-rays. We can see them in the optical, in the ultraviolet, in the infrared. Various NASA missions have been great at finding black holes. And then more recently, the really exciting way to find black holes is when two black holes merge, they create ripples in space-time, and you can detect that from gravitational wave observatories.
One big mystery about astronomical black holes is how the large supermassive black holes that exist at the center of almost every galaxy actually got to be there.
Another critical question is really what happens beyond the event horizon. What is essentially inside the black hole? The real reason we want to know about these, as interesting as they are on their own, they are all connected with our general understanding of the physics of the universe.
We're seeing black holes bigger than we had seen before. We're seeing black holes that weigh 100 times the mass of the sun. And right now the community's trying to figure out where they're created.
Einstein himself did not think such things would exist. Other people using his theory said we could have things like this, like black holes. And now it's become sort of a bread and butter kind of study on many levels to the point of us imaging them directly. I think it's one of the great stories of how science works, from pursuing ideas in terms of purely theoretical thought, but then observations coming in and then merging the two to have a better understanding of the universe.
The first black hole ever confirmed, Cygnus X1, was first discovered back in 1964, when astronomers identified high-energy X-rays captured by a sounding rocket. Since then, NASA has launched a number of different missions and studies to further investigate black holes. These have included NASA's Chandra X-ray Observatory, the Hubble Space Telescope, NuSTAR, the James Webb Space Telescope, and many more. These are just a few examples of NASA's continued efforts to expand our understanding of black holes. Thankfully, as humans living on planet Earth, we will never be close enough to any black hole, including the supermassive black hole at the center of our own galaxy, to ever be in danger of falling in. I promise.